Okay, so let's continue our discussion of sums for arithmetic and geometric sequences or series. We're going to talk about something called summation notation, which is a shorthand. Remember, a series can go on forever, so you could have infinitely many terms. The examples that we've been working on in our lessons are limited in the number of terms that they have. But if you had, for example, 1,000 terms or 500 terms, well, obviously you could spend your whole sheet of paper writing all those terms down, and it would also take a lot of time to calculate those values. So there's a shorthand or a much quicker way of writing these series, especially these bigger series, and it's called summation notation. Now, summation notation, the big new symbol here is the Greek alphabet capital letter sigma. And sigma is used to denote that we're finding the sum for a series. At the bottom of sigma, we're going to say n equals, and whatever term we're going to start with. The value that we start with could be a 0, a 1, a 10, a 15. We can put anything in here for n. This is just telling us where do we start in the sequence counting or finding the sum. The top of our sigma is where we would end, the value that we would end with, or the term that we would end with. So the bottom tells us where to start, like n equals 1. The top tells us where to end. We want to find the first 5 or 6 terms. Now, the rule that you see stated here would come from either an arithmetic sequence, which is here's our formula for that, or a geometric sequence. And we've already practiced of how to write the rule for an arithmetic or geometric sequence. So for example, let's say that you were asked to expand this notation and find the sum. So what they've given us is the fact we want to start with the first term and we want to end with the 5th term. So these are going to be the values for n that we're going to substitute into this formula, which is the rule for our sequence. So for example, we're going to start with n equals 1 and we're going to find a value. And then we're going to substitute in n equals 2 and we're going to find a value. And then we're going to substitute in n equals 3 and we're going to find a value, and so forth and so on until we have found 5 values, because that says where we stop. So let's do the math very quickly. If I put in a 1 here for n, okay, this 1 is going to go in for n, and I'm going to end up with 2 times 1 minus 1. Well, 2 minus 1 is 1. So that would be the value of my first term. And now we're going to add that to n equaling 2. So this would become 2 times 2 minus 1, which would be 4 minus 1, or 3. That's the value of my second term. My third term would be 2 times 3 minus 1, 6 minus 1, which is 5. That's my third term. My fourth term would be 2 times 4 minus 1, which is 7. And now we've done enough that we start to identify a pattern. This looks like it's arithmetic, and it looks like it's increasing by 2. So I could probably go ahead and make a guess here that my last term's value is going to be 9. Let's go through the math to make sure. 2 times 5 minus 1, well, 10 minus 1 is in fact 9. Now at this point, I could just add all of these numbers together and end up with the sum for this, or I could use my formula. If I add up all the values together, I'm going to get a sum of 25. Let's see if I get the same thing if I use my formula. My first term is a sub 1. My fifth term is a sub 5. So these are the two values I would need to use my sum formula. The sum of the first 5 terms would be equal to the number of terms, which is 5, times the first term, which is 1, plus the last term, which is 9, all divided by 2. As you can see, I end up with 5 times 5, which is in fact 25. So I was able to calculate the sum using the formula as well as using just common sense and adding up my terms. What would this look like with the geometric series? Well, the same thing would hold, except remember your a sub n is different. It's the first term times r to the n minus 1. I want you to pay close attention to this formula and how it translates down here into this expression. I think it's very easy to see that 2 is my first term and that r is 3. That's going to become important in just a minute. Let's see if we can find our values. Once again, they want us to start with our first term. They want us to end with 4 terms. So I have to count to 4. N equals 1, n equals 2, n equals 3, n equals 4. Let's do some calculations now. 2 times 3 to the 1 minus 1 power, well 1 minus 1 is 0. 2 times 3 to the 0 power is 1, so I end up with a value of 2 here. 2 times 3 to the 2 minus 1 power, well 2 minus 1 is 1, so I end up with 2 times 3, which is 6. I'll put my plus in between here. 2 times 3 times 3 minus 1 is going to give me 2 times 3 squared. 3 squared is 9, times 2 is 18. And I'm starting once again to identify a pattern. However, this is a geometric series, so we're multiplying by 3. So my guess for my next term is going to be 54, because 18 times 3 is 54. Let's see if that's true. 2 times 3 raised to the 4 minus 1 power will give me 2 times 3 to the 3rd power. 3 to the 3rd power is 27, and 2 times 27 is in fact 54. Now once again, I could add all of these numbers up, and I would end up with a sum of 80. So the sum of the first 4 terms of the sequence, 2 times 3 to the n minus 1, is 80. I could also use my formula, s of 4 terms is equal to the first term plus 1 minus r to the n all over 1 minus r. I know some are probably looking at this and saying, I would much rather just add everything up. But keep in mind again, if this would have been 44 terms, then this formula would definitely save you. So my first term here again is 2. 1 minus r in this case is 3, to the 4th power, all divided by 1 minus 3. Finishing this up now, I get 2 times 1 minus 81, because 3 to the 4th power is 81, all over 1 minus 3, which is negative 2. I end up with 2 times 1 minus 81 is 80, negative 80, I'm sorry, all over negative 2. And at this point, I could just reduce, cross out the 2's, get rid of my negatives, and I end up once again with 80. So whether I use my formula or I just found each term and added them up, the sum of the first 4 terms would equal 80. Now, what if I'm asked to find the sum of, say, 22 terms? Do I really want to write out 22 terms and add them all together? The answer to that question is no. Remember, my formula says that what I need is the number of terms I need the first term's value, the last term's value, all divided by 2. That's the formula. Do I know how many terms I want? Yes, I do. 22. Do I know the first term's value? Well, I don't. How do I figure that out? Well, that's quite simple. I simply say n equals 1, and I figure out what that value is. 3 times 1 plus 2. 3 times 1 is 3 plus 2 is 5. So that value is important to me. But I really don't need the other values. What I need is the last term, because that's the formula. So now what I do is take 3 times 22 plus 2, which is going to give me 66 plus 2, or 68. There is my value of my 22nd term. Now substitute into my formula. The number of terms is 22. My first term is 5. My last term's value is 68, all divided by 2. Continuing on, 5 times 5 plus 68, of course, is 73, all divided by 2. Now, of course, 73 divided by 2 is 36.5, so I end up with 5 times 36.5, which gives me a sum of 803. Once again, you can choose either way you want to do the problem. It's much easier using the formula here because we needed to find so many terms. Let's try one that's geometric. Again, just a different formula here. Could I do the same thing? Well, in this particular problem, my formula here relies on the first term, my common ratio, the number of terms, and that's all I need to find my formula. I don't need the value of my last term. All I need is the first term, the common ratio value, and the number of terms. Let's see how much I can figure out without having to find a bunch of terms. My common ratio, for example, can I figure that out by what's written here? It looks like it's 2. And the number of terms is very easy. That's fine. So let's write our information over here. The number of terms is 5. We know that. But the first term we're not completely sure of. And my R we're not completely sure of. So let's see if we can write out a few terms here. So once again, I'm going to do like 3. N equals 1. N equals 2, and n equals 3. Again, I don't need the last term. I'm just doing enough to find a common ratio here. I think it's 2, but I want to be sure. So this first term value would be 2 raised to the 1 minus 1, which would be 2 to the 0 power, which would be 1. So my first term's value is actually 1. My second term would be 2 raised to the 2 minus 1 power. 2 minus 1 is 1, so I get 2 to the first power, which is just 2. Put my plus there. And now my third term, I end up with 2 raised to the 3 minus 1 power. 3 minus 1 is 2. 2 squared is 4. And I'm starting to identify a pattern now. I'm multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. So my R is in fact 2. Now that I have everything that I need, I can simply substitute into my formula. My first term is 1. I get 1 minus my R value, which is 2, raised to the 5th power, all divided by 1 minus 2, which gives me 1 times 1 minus 32, all over negative 1. Okay, 1 minus 32 is negative 31 all over negative 1. So I end up with a sum value of 31. Once again, how you choose to do the problem is totally up to you. You can write out each term and add everything together, or you can use your formula. So now that we know how to use summation notation, let's talk about how to write using summation notation. And you're already experts at it. All I really need to do is to write the rule. So I'm going to treat this as if this in fact is an arithmetic sequence. It is an arithmetic sequence because by inspection I'm increasing by 4. So what I want to do first is find the rule. To find the rule, I simply say a sub n is equal to the first term plus n minus 1 times d. My first term is 2. The number of terms I'm not concerned about, because remember I'm treating this as if it goes on forever. But my common difference is 4. Cleaning this up now by distributing the 4, I end up with 4n minus 2. So I can find any term in my sequence by substituting in the term that I want, multiplying by 4 and subtracting 2. Since I know the rule, I can now write using summation notation. So here comes my sigma. I'm going to start with my first term, so n equals 1. There are 1, 2, 3, 4, 5, 6, 7 terms, so I'm going to put a 7 up top. And now I'm simply going to take my rule, 4n minus 2, and there is sigma notation for this series. What about geometric? Well, again, I have to identify if it's arithmetic or geometric first. This particular series is in fact geometric. My r value can be found by taking 3 and divided by 1, which is 3. And as you can see, 9 divided by 3 is 3, 27 divided by 9 is 3, and 81 divided by 27 is 3. Now again, to write summation notation, which I'll go ahead and start over here, I'm going to start with n equals 1, and keep in mind they don't always start with 1. Okay? They can start with 0, but in this case, in what we're writing, this is our first term, so we're going to start with 1. There's 1, 2, 3, 4, 5 terms, so we're going to put a 5 up top. Now we need to figure out what our a sub n formula is for any term in our sequence. And for geometric, it's the first term times r raised to the n minus 1 power. We know our first term's value is 1, so this is simply 1 times 3 raised to the n minus 1 power. And this, without any hard work, is simply our formula. We come over here and we write 3 to the n minus 1 power. And here is our summation notation for the series 1, 3, 9, 27, and 81. So we have to make the decision early on when we're writing using summation notation. We have to decide which formula we're going to use. We need to know where we are starting, which term. In most cases it will be 1, but not always. It could be 0, it could be 10, it could be 11. It just depends on the problem. And then how many terms are we finding the sum for? Is it the next 10 terms? The next 15 terms? And then we have to decide what is the rule. If it's arithmetic, then we use the formula, the first term plus n minus 1 times d. If it's geometric, then we use the formula, the first term raised to r to the n minus 1 power.